Good morning children. Last class we had discussed about the oxidation numbers of the different atoms in a compound and the different methods to find out the oxidation number of those atoms in a compound or in an ion. Okay. We are also discussed that what is oxidation and reduction reactions based on oxidation number. So, what was oxidation reactions defined in terms of oxidation number? The oxidation reactions are those reactions in which the atoms increase in their oxidation number. The part of the reaction in which the oxidation number increases in a particular reaction, then that will be called as the oxidation, and if the oxidation number is decreasing in a particular reaction for an element, then that will be called as reduction. Okay. So, that things we had discussed in the previous class. Now, today we will discuss what is oxidizing agent in terms of oxidation number. What is reducing agent in terms of oxidation number? In terms of electron transfer, what was oxidizing agent and what was reducing agent? Reducing agents were those which had the tendency to lose electrons. Reducing agents in terms of electron transfer concept, they were the substances which had the tendency to lose electrons, and oxidizing agents were the one which had the tendency to gain electrons. Now, here we will understand oxidizing and reducing agents in terms of oxidation number. ठीक है, तो कैसे होगा oxidizing agents? How can we define it? The substance in which the oxidation number of an atom decreases is called as oxidizing agent. यहाँ पे atoms का अगर oxidation number decrease हो जाता है, then that will be your oxidizing agent. एक एग्जाम्पल लेके समझते हैं. देखो यहाँ पे Cl2 is having what oxidation number? It is in the elementary form. That means Cl2 will have 0 oxidation state, or it goes to, when it is forming HCl, the oxidation number of Cl is -1 because H will carry positive 1 charge. So, chlorine will be having -1 charge. So, what do you see here? The oxidation number of chlorine is going from 0 to -1. So, matlab there is a decrease in the oxidation number of Cl. Therefore, Cl will be called as the oxidizing agent. Okay. So, here what do you find? Decrease in oxidation number. Decrease in oxidation number होता है. Therefore, it will be called as oxidizing agent. Are you understanding that? Okay. Ab one another example we can take. Let me take here. What is the oxidation state of Mn here? Here the oxidation state of Mn will be, you can calculate it. MnO2 है ना, तो Mn का हम X ले लेते हैं. ऑक्साइड फॉर्म में है, मतलब ऑक्सीजन का -2 ऑक्सीडेशन स्टेट होता है. ओवरऑल चार्ज इट इज 0. Therefore, x -4 इक्वल टू 0. सो x इज इक्वल टू 4. यहाँ पे +4 ऑक्सीडेशन स्टेट है MnO2 का, MnO2 में Mn का. ठीक है. While when I come here, what is the oxidation state of Mn? It is 4. It is 0 because it is in the elemental form. So, you can find here that the oxidation number of Mn decreases from 4 to 0. So, what is it? Oxidation number of Mn decreases. Therefore, Mn is oxidizing agent. Okay, Mn is oxidizing agent. Here Cl is, or Cl2 is oxidizing agent. यहाँ पे हम सिर्फ Mn नहीं बोलेंगे, MnO2 बोल देंगे. Okay, MnO2 is the oxidizing agent because in MnO2 you are finding that Mn का oxidation number is decreasing. Got it? So, that is oxidizing agent. Got it? नेक्स्ट, रिड्यूसिंग एजेंट्स को कैसे डिफाइन करते हैं? द सब्सटेंस इन विच द ऑक्सीडेशन नंबर ऑफ एन एटम और एटम्स इंक्रीज, दैट इज कॉल्ड एज रिड्यूसिंग एजेंट्स। ठीक है, जैसे HNO3, ठीक है, और अदर यू विल टेक S, क्योंकि इधर S का ऑक्सीडेशन नंबर क्या है? इट इज 2 into +1 plus x equal to 0. So therefore 2 plus x is equal to 0. So x will be equal to -2. यहाँ पे S का ऑक्सीडेशन नंबर इज -2. लेकिन when we come here, what do you observe? कि ऑक्सीडेशन नंबर ऑफ सल्फर इज बिकमिंग 0. ओके, सो द ऑक्सीडेशन नंबर ऑफ सल्फर इज इंक्रीजिंग फ्रॉम -2 to 0. इंक्रीज ही हो रहा है ना, -2 से वो 0 पे जा रहा है. सो इट इज इंक्रीजिंग. सो हियर यू हैव ऑक्सीडेशन नंबर ऑफ सल्फर increases from -2 to 0. Therefore, H2S is the reducing agent. Therefore, H2S is the reducing agent. Clear? So, that is what you are observing here. बाकी H का +1 ही रहेगा, यहाँ पे भी +1, यहाँ -2 रहेगा, इधर भी -2 ही रहेगा. अब इसी रिएक्शन में यू कैन ऑब्जर्व कि HNO3 में जो N है उसका ऑक्सीडेशन स्टेट है क्या है, हम कैलकुलेट कर लेते हैं. H का +1 है, N का हम X रखते हैं, 3 into -2 which is equal to 0. So X -6 + 1 equal to 0, that is X is equal to +5 आता है इन HNO3. और NO में क्या होगा, NO जो है उसमें N का ऑक्सीडेशन स्टेट विल बी, अब ऑक्सीजन का -2 है, ऑक्साइड फॉर्म में है तो -2 होगा, तो N का +2 होगा. सो व्हाट डू यू ऑब्जर्व हियर, N is having a +5 oxidation state and here N is having a +2 oxidation state. So here there is a decrease in oxidation number of nitrogen. Therefore, HNO3 is oxidizing agent. Oxidizing agent. तो उसी तरह से हम ऊपर भी फाइंड आउट कर सकते हैं. यहाँ पे there is decrease in oxidation number for chlorine. Similarly, you will find there is an increase in the oxidation number of I, because here I has a -1 oxidation state, here I has a 0 oxidation state. Okay, तो यहाँ पे increase हो गया ना oxidation number का. You can see here there is a increase in oxidation number. increase हो रहा है oxidation number का. तो अगर increase हो रहा है oxidation number मतलब ये क्या हो गया, this becomes your reducing agent. So HI is the reducing agent in this reaction and Cl2 is the oxidizing agent in this reaction. Here you will find that Al which is having 0 oxidation state है ना, Al is the elemental form, तो यहाँ पे 0 oxidation state में है, जबकि यहाँ पे वो +3 फॉर्म में आ गया. Al will go into +3 oxidation form. So it is increase in the oxidation number. अगर ये increase हो रहा है oxidation number मतलब वो क्या हो गया, reducing agent. Clear? So I hope you understand what is oxidizing and reducing agents in terms of oxidation number. Okay? So this is how you should be understanding it. Please note down. Now we go to the next topic, that is oxidation number and nomenclature. Now certain compounds are there like Cu2O and CuO. Both are oxides of copper, but you will find that the oxidation state of copper in this particular oxide, it is in the form of Cu+1 and O2-. ठीक है, जबकि ये जो ऑक्साइड है कॉपर ऑक्साइड, इट इज एग्जिस्टिंग एज Cu+2 O2-. कैसे पता चलेगा हमें, देखो ऑक्सीजन in normal condition in the form of an oxide it will always carry -2 charge. ये हमने rules में learn किया था when we were assigning rules to how to assign the oxidation number to various elements. So there we had learned that oxygen in normal condition, that is in normal oxides, it will always have -2 charge. जबकि copper का oxidation state can vary. Okay. So in this particular oxide also oxygen will carry -2 charge. So naturally copper will carry +1 charge. There are 2 copper atoms, so 2 copper ions will together give +2 charge, okay, and the compound is neutral. So here you will find that the copper is in the +1 charge, here the copper is in the +2 charge, +2 oxidation state. So there is a specific way of giving a notation to these kind of oxides, and that is called as stock notation. What is it called as? Stock notations, to indicate the oxidation number of the elements with varying oxidation state. For example, Cu2O, it is written as, here what is the oxidation state of copper? It is 1. So it will be Cu2 1. We write that +1 oxidation state to indicate that we use the Roman numeral, okay, 1O. इस तरह लिखते हैं. This is the stock notation method, okay, for giving a name to this oxides, this kind of oxide, okay. Other is CuO. So कैसे लिखेंगे? Cu with +2 oxidation state, oxygen, okay. Another example, say FeO. अब FeO में what is the oxidation state of Fe? How do we come to know? Oxygen का -2 है, तो naturally Fe का क्या होना चाहिए? +2 होना चाहिए, तभी तो न्यूट्रल कंपाउंड बनेगा. So here you have Fe2O. वो +2 स्टेट में है, ऐसे हमें पता चल जाएगा. This method is known as stock notation method. Another जैसे Fe2SO4 thrice. अब ये वाला कैसे notation देंगे हम इसका? Here what is the notation you will give? First you find out what is the oxidation state of Fe+2. SO4 में Fe का oxidation state find करना है. So it is this way, no? You know that SO4 always carries a -2 charge. Okay. So therefore this is unknown to us, so we can write it as 2x plus, ये पूरा आयन के ऊपर चार्ज -2 होता है, so 3 into -2 which is equal to 0. Okay. So I have 2x is equal to 6, so x is equal to 3. Yes or no? So Fe in this case is in the +3 oxidation state. तो मैं कैसे लिखूंगी? Fe2 thrice Fe2 twice SO4 thrice. This is the notation for FeSO4 thrice. Are you understanding? तो इस तरह से this kind of the notation to show the molecular formula of a compound is called as stock notation method. Many other compounds you can take. Say for example KMnO4. KMnO4 में K का तो +1 ही रहता है, O का भी -2 ही रहेगा, बट Mn का ऑक्सीडेशन स्टेट कैन वेरी. इट कैन बी +7, इट कैन बी +4, कैन बी +2. ओके. सो KMnO4 में व्हाट इज द ऑक्सीडेशन स्टेट ऑफ Mn? Mn का ऑक्सीडेशन स्टेट, दिस इज MnX ले लेते हैं, K का +1 +4 into -2 equal to 0. So therefore X +1 -8 equal to 0. So X is equal to 7 आ जाएगा. So Mn का oxidation state is +7. So therefore how do you K Mn7, okay, O4. This way you will give the notation. Okay. A few more we will take. K2MnO4. We can take this. We can take K2Cr2O7. Okay. या फिर MnO2. So many examples we can say. So this is the different molecules for which we can give the stock notation method. Say for example K2 that was KMnO4. This is K2MnO4, that is 2x, x plus 2 plus minus 8 equal to 0. So x will be equal to 6 हो जाएगा ना, minus 6 इस तरफ जाएगा तो 6. So how do we represent this? This we can represent it as K2Mn6O4. Got it? So this is how you will represent this. K2Cr2O7 कैसे represent करेंगे? उसके लिए पहले Cr, K और O का तो सेम ही रहेगा, Cr का डिफर करेगा. So K2 that means 2 into plus 1 plus x, और 2 क्रोमियम है मतलब 2x लिखेंगे, plus 7 into minus 2 which is equal to 0. Okay, so I have 2x, 7 into minus 2 will be minus 14 plus 2 12 हो जाएगा equal to 0. So 2x is equal to 12, x will be equal to 6. Okay, so ये यहाँ पे कैसे हम represent करेंगे? K2Cr2, oxidation state of chromium is 6O7. This is the stock notation method of K2Cr2O7. Okay, MnO2, how will we show? Mn will have what oxidation state? यहाँ पे Mn will be x plus 2 into minus 2 equal to 0. So x will be equal to 4. So we have Mn4O2. I hope you understand this. So this is what we call as stock notation method for various molecules, where you find there are atoms which are existing in the variable oxidation state. Okay, note this down. Now let us discuss about types of redox reaction. Now redox reaction ऐसा होता है जहाँ पे you will find oxidation also occurring and reduction also occurring. So let us take these examples and see whether this is a redox reaction or not. So here C is in the elemental form, मतलब उसका oxidation state 0 होगा. O2 is also in the elemental form, it will be having oxidation state 0. Here carbon will be having +4 oxidation state and oxygen will be having -2 oxidation state, isn't it? यहाँ पे x -4 equal to 0, so x will be equal to +4, that is C is having +4 oxidation state. So here C goes from 0 oxidation state to +4 oxidation state. That means oxidation is occurring, increase in oxidation number. So therefore that is oxidation. इसको हम oxidation reaction कहेंगे. And O2 is going from 0 oxidation state to -2. मतलब ये तुम्हारा reduction reaction हो गया, isn't it? So this is a redox reaction. And here what do you observe? That one of the atom and one molecule, it combines together to give you a new molecule. Then this kind of a reaction where two atoms or two molecules or an atom or a molecule combine to give you the third molecule, then that will be called as a combination reaction. Okay, so general way में हम कैसे represent कर सकते हैं? A plus B combines to give you C. Okay, so this is a redox combination reaction which is redox in nature. ठीक है, तो हम define कैसे कर सकते हैं? The reaction in which two atoms or molecules combine to give a third molecule is called as combination reaction. Is called as combination reaction. Is called as combination reaction. ठीक है, वैसे ही हम Mg और N2 का भी देख सकते हैं. Mg is an atom, N2 is a molecule. यहाँ पे 0 ऑक्सीडेशन स्टेट है दोनों का. यहाँ पे Mg का ऑक्सीडेशन स्टेट +2 होगा, नाइट्रोजन का -3 होगा. सो Mg goes from 0 ऑक्सीडेशन स्टेट टू +2 ऑक्सीडेशन स्टेट, मतलब ये तुम्हारा ऑक्सीडेशन प्रोसेस हो गया, दिस इज योर ऑक्सीडेशन प्रोसेस, एंड N2 goes from 0 to -3 ऑक्सीडेशन स्टेट, तो मतलब ये तुम्हारा दिस बिकम्स योर रिडक्शन. Followed or not? Okay. So that is combination reactions which are one of the type of the redox reaction. Here oxidation reduction both are occurring, please note that. Second type of reaction is decomposition reaction. Ab decomposition, as the name suggests, the bigger molecule is broken down into two or more smaller products in such a way that one of the products should be in the elemental form. Then only it will be called as decomposition reduction reaction or redox reaction. Every decomposition reaction you cannot say it as redox reaction. All decomposition reactions are not redox reactions. Decomposition reactions कौन से होते हैं? जो जहाँ पे a bigger molecule is broken down into smaller molecule. जैसे ये देखो H2O which is a molecule, it is broken down into H2 and O2 smaller molecules. तो ये decomposition reaction हो गया. लेकिन ये decomposition reaction redox है. Let us check. Here H2 is having +1 oxidation state, oxygen is having -2 oxidation state. और इधर H2 is in the elemental form, therefore 0 oxidation state, O2 0 oxidation state पे है. So H is having or it is moving from +1 to 0, मतलब ये नंबर कम हो रहा है उसका, that is reduction. O is moving from -2 to 0, मतलब इंक्रीज हो रहा है ना उसका ऑक्सीडेशन नंबर, so therefore this is ऑक्सीडेशन. मतलब ये जो डिकम्पोजिशन रिएक्शन है that is a redox reaction. तो अगर any decomposition reaction you have to define it under the redox reaction, then one of the products should be in the elemental form. In this reaction you can see both of them are in the elemental form. So therefore this is a redox reaction, decomposition reaction which is a redox reaction. ठीक है. Similarly KClO3 getting decomposed to KCl and O2. Again you can see O2 is in the elemental form, मतलब ये redox reaction है. Even it is a decomposition reaction because KClO3 is broken down into two smaller molecules. Okay. So Cl जो है, what is the oxidation state? Let us calculate. यहाँ पे Cl का -1 होगा, यहाँ Cl it will be 1 plus x minus 6 is equal to 0, so x5 होगा. यहाँ पे Cl is +5 oxidation state. Okay. सो +5 से -1 गया, मतलब रिडक्शन हो गया उसका, द नंबर इज रिड्यूसिंग, सो दिस इज रिडक्शन. जबकि ऑक्सीजन जो कि -2 ऑक्सीडेशन फॉर्म में था, इट गोज टू 0 ऑक्सीडेशन स्टेट, सो दिस इज इंक्रीज इन द ऑक्सीडेशन नंबर. -2 से 0 गया, मतलब देर इज एन इंक्रीज इन द ऑक्सीडेशन नंबर, सो दिस इज योर ऑक्सीडेशन प्रोसेस, दिस इज योर रिडक्शन प्रोसेस. ओके, सो दिस इज अ डिकम्पोजिशन रिएक्शन विच इज a redox reaction. ठीक है. Same way NaH goes into Na plus and H2, Na and H2 sorry. So Na यहाँ पे +1 oxidation state पे है, this is +1 and this is -1. Okay. So Na goes from +1 to यहाँ 0 oxidation state आ गया ना, तो ये +1 से 0 reduce हो गया, मतलब this is रिडक्शन रिएक्शन, ऑक्सीडेशन नंबर का डिक्रीज है यहाँ पे. एंड H विच इज इन -1 स्टेट, इट इज गोइंग फ्रॉम -1 to 0, मतलब दिस इज ऑक्सीडेशन. ओके, सो यू अंडरस्टैंड नो हाउ यू कैन डिफरेंशिएट डिकम्पोजिशन रिएक्शंस. Decomposition is breaking a bigger molecule into smaller molecule in such a manner that one of the products should be in the elemental form. Then we can call it as redox reaction. Okay, decomposition reaction which is redox in nature. अब ये वाला example लेके देखो, CaCO3. This is also decomposition reaction, isn't it? A bigger molecule is broken down into two smaller ones. But is it a redox reaction? You can just check. देखो कैल्शियम का हमेशा +2, एल्कली मेटल्स हमेशा +1 ऑक्सीडेशन स्टेट में रहेगा, और एल्कलाइन अर्थ मेटल दैट इज ग्रुप 2 एलिमेंट्स विल ऑलवेज रिमेन इन +2 ऑक्सीडेशन स्टेट, तो वो +2 में जाएगा. ओके, ऑक्सीजन का -2 रहेगा, तो हम C का फाइंड कर ही सकते हैं यहाँ पे, दैट इज +2 + x + 3 × -2, so 2 + x - 6 is equal to 0, so x will be equal to 4, यानी कार्बन यहाँ पे +4 पे रहता है, यहाँ पे कैल्शियम +2 ऑक्सीजन -2, कार्बन +4 ऑक्सीजन -2, यहाँ पे कुछ भी ऑक्सीडाइज रिड्यूस हो नहीं रहा है, ओके, because all of them are having the same oxidation state. So this is not a redox reaction, it is not redox reaction, it is not a redox reaction, okay. How can you define redox decomposition reaction? The reaction in which a bigger molecule is broken or decomposed, you can write broken into 2 or more products such that one of the product remains in elemental form is called as decomposition reaction, which is redox in nature, okay. ये भी decomposition reaction ही है, but this is not redox reaction, okay. तो अगर हम decomposition reaction under types of redox reaction define करते हैं, तो it should have one of the product as elemental part, okay. So note down. The next kind of redox reaction is displacement reaction. Now displacement reaction means, see, you observe this reaction, what is it? CuSO4 plus Zn gives you ZnSO4 plus Cu. Now CuSO4 में से Cu को displace किया गया, by whom? By a active metal, okay, and it forms what? ZnSO4. तो यहाँ पे एक मेटल को अपने सॉल्ट में से डिस्प्लेस किया गया है, ओके. सो दिस इज मेटल डिस्प्लेसमेंट रिएक्शन, ओके. अगर तुम इसको एक स्पेसिफिक नाम देना चाहोगे तो इट विल बी मेटल डिस्प्लेसमेंट reaction. What is the definition of this displacement reaction? It is the reaction in which an atom or an ion is displaced from a compound by an atom or an ion from the other compound, then that will be called as displacement reaction. तो यहाँ पे metal displacement इसलिए कहते हैं क्योंकि a metal is displaced from the salt by another metal, okay. So here what is the oxidation state of Cu? It will be +2, SO4 का -2 है, यहाँ Zn is 0 oxidation state, यहाँ पे Zn +2 oxidation state, सल्फेट का -2 रहेगा और यहाँ कॉपर 0 ऑक्सीडेशन स्टेट में है. तो कॉपर इज गोइंग फ्रॉम +2 ऑक्सीडेशन स्टेट टू 0, मतलब कॉपर इज गेटिंग रिड्यूस्ड. तो दिस पार्ट ऑफ द रिएक्शन इज रिडक्शन रिएक्शन एंड Zn इज गोइंग फ्रॉम 0 टू +2 ऑक्सीडेशन स्टेट, मतलब ये जो पार्ट है दिस इज योर ऑक्सीडेशन रिएक्शन एंड कॉपर मूविंग टू from -2 to 0, that will be your reduction reaction, ठीक है. Similarly here what do you observe? The H2O में से H is being replaced by Na to give you NaOH, okay, and H2 is formed. So this is also Na is displacing H from H2O. So this is a reaction which we call it as non-metal displacement reaction, Have you understood? So this is, again you can observe, this is having zero oxidation state. Here +1 है, यहाँ -2 है, यहाँ Na के पास +1 ऑक्सीडेशन स्टेट है, OH माइनस का -1 ऑक्सीडेशन स्टेट है और H2 का 0 होगा. सो H इज गोइंग फ्रॉम +1 to 0, दैट मीन्स ये रिडक्शन है. एंड Na इज मूविंग फ्रॉम 0 to +1, मतलब ये तुम्हारा ऑक्सीडेशन रिएक्शन हो गया. ओके, सो द रिएक्शन इन विच one of the atom or an ion from a compound is displaced by another atom or ion of the other compound, then that will be called as a displacement reaction. Okay, you can write it down from the textbook. The textbook, the definition is given to you. I hope that is clear with you. So this is your displacement reactions, okay, which are redox in nature. Then coming to the fourth one, which is called as disproportionation reaction. Disproportionation reactions are, you can define it in which this way, the reaction in which the same species is getting oxidized and reduced. The reaction in which the same species is getting oxidized and reduced is called as disproportionation reaction. Disproportionation reaction, ठीक है. ये एक एग्जाम्पल ले लेते हैं, वेरी कॉमन एग्जाम्पल. फर्स्ट वी विल फाइंड द ऑक्सीडेशन स्टेट्स. H2 का H का इन दिस कंपाउंड विल बी +1. H हमेशा +1 ही रहेगा, एक्सेप्ट इन मेटल हाइड्राइड्स इट विल हैव -1. अब ये कौन सा कंपाउंड है? दिस H2O2, नो, इट इज हाइड्रोजन पेरोक्साइड. इट इज हाइड्रोजन पेरोक्साइड. और जब पेरोक्साइड्स होता है तब what was the oxidation number assigned to oxygen? In this case the oxidation number of oxygen will be -1. ये भी हमने जब रूल्स लर्न किया था तब अंडरस्टैंड किया था ये. ओके, सो हियर ऑक्सीजन विल हैव अ -1 ऑक्सीडेशन नंबर. अब यहाँ पे देखते हैं H2 +1 है. वाटर में ऑक्सीजन का ऑक्सीडेशन स्टेट -2 होता है और इधर ऑक्सीजन इज इन द एलिमेंटल फॉर्म, मतलब ऑक्सीडेशन स्टेट उसका 0 है. ठीक है. अब ये दोनों H का तो +1 दैट मीन्स इट इज नॉट नाइदर गेटिंग ऑक्सीडाइज नॉर ये रिड्यूस्ड. ये तुम्हारा स्पेक्टेटर आयन है. बट ऑक्सीजन यू कैन सी इट इज मूविंग फ्रॉम -1 to -2 इन दिस वे. तो ये तुम्हारा ऑक्सीजन का रिडक्शन बताता है यहाँ पे. सेम वे दिस ऑक्सीजन इज गोइंग फ्रॉम -1 to 0, मतलब यहाँ पे हो गया तो मतलब ये तुम्हारा ऑक्सीडेशन हो गया. दिस इज योर रिडक्शन. तो सेम स्पीशीज दैट इज सेम ऑक्सीजन आयन इज गोइंग इनटू द रिडक्शन फॉर्म एंड द ऑक्सीडाइज्ड फॉर्म. ऐसे जो रिएक्शंस होते हैं जहाँ पे सेम स्पीशीज इज गेटिंग ऑक्सीडाइज्ड एंड रिड्यूस्ड, दैट विल बी कॉल्ड एज द disproportionation reaction. I hope this is clear. So we have learned 4 different kind of redox reactions: combination reactions, displacement reactions, decomposition reaction and disproportionation reactions. Okay, I want every one of you to go through the textbook, read the part and try to understand it. Okay, and you can make a note, types of reactions, type of redox reactions. Okay, and each of them define it and give an example to make it clear. Okay, thank you.